Hello, my wonderful AP Statistics students. Welcome to another lesson in Unit 1, Exploring One Variable Data. I'm Goldie, and I'm here to take you through Notes 5, which is over Boxplots and Outliers. Now, in this lesson, we are going to be covering some summary statistics that we have not covered before, including the 5-number summary and the IQR. And we're going to talk about how we use those to construct box plots, and then also how we use those to mathematically determine outliers in our data set. So we're going to do all of that in the notes today. So grab your notes, get settled in, and we'll go through this content together. First, the 5-number summary. Now we know percentiles measure the percent of observations that fall below a value. We've learned this, we've done this, but we have special percentiles in a data set that we want to draw attention to. The first one we've learned about is the median. Now the median is the middle of a data set, of an ordered data set, it should be said, an ordered data set where 50% of the observations fall above and 50% fall below. And the median is what we consider the 50th percentile. So we've talked about that special percentile before, but there's other special percentiles you're going to want to know for AP statistics. And the first one is the 0th percentile. Or the minimum. It's the lowest value in a data set. There is no data below the minimum value, which is why it's the 0th percentile. Okay, the absolute lowest value is the minimum. Next, we have the 25th percentile. We call this the first quartile, or Q1, and it represents 25% of the data is below whatever this value is. Of course, the 50th percentile is the median, the middle value of the data set. You can probably see where this is going. The next one is the 75th percentile. We call that the third quarter, the third quartile, because it's the third quarter kind of thing, or Q3, where 75% of the data is below that value. So you can see how we are splitting it up into quarters, right? The 20, 25, 50th, 75th, right? Those are quarters. The median you could call the second quartile if you wanted to be fancy, but it is the median, okay? And then the 100th percentile is the maximum. It's the highest value in the data set. And remember, how we calculate percentiles in AP statistics is it's the value at, we calculate it at or below. So 100th percentile would be the maximum value just based on how we calculate it in AP statistics. Okay, so these 5 numbers together make up what we call the 5-number summary. We have the minimum and maximum, the median, and then those 2 quartiles, the first quartile and the third quartile. Okay, now to calculate these values by hand, which I'm going to show you, you're going to want to know, we place the observations in order from lowest to highest, and then we can find all 5 of these values. We find the middle first. The median is the easiest. Well, I guess min and max are technically the easiest, right, Goldie? Min and max are the easiest. The median we can find. We've done that by hand before too. And then we find the quartiles on either side of the median. Okay. So here's data from a previous statistics class. I asked them how many hours of sleep they got before the first day of school. Okay, so here's the data in order from lowest to highest, and we're going to find the 5-number summary by hand here. So of course the minimum, when the data is in order from lowest to highest, the minimum and the maximum are easy to find there. And then our median, remember we count in to find that middle value. And here, because it's an even list of numbers, the middle value is between 2 numbers, but the 2 numbers in the middle are a 7, so the median's a 7. Right? So if we have an even list of numbers, we take an average of the 2 center numbers to find that true middle. And in this case, it's just 7, right? So that's our median. And those are pretty straightforward. We've done those before. Now to find the quartiles are, some people describe them as like the median of the median. Okay, they're going to be the middle value on either side of the median. So like Q1 here, we count from the lowest and then on, not including the median, but the number right next to the median, the one lower than the median, right? And we count down, we count 5 values in, and that puts us at 6. And 6 is going to be our first quartile there. Okay, so you can see why some people call it the median of the median, right? Because it's the middle of the left side of the median. And then Q3 is going to be found by finding the middle of the right side of the median, okay? Again, not including the median value itself. So in this case, we start here and we count 5 values. And then we start here and we count 5 values. And this is our middle number 8, and that's going to be our Q3. Now, sometimes our quartiles are going to fall between 2 values, and we find them just like we do the median, where we take the average of those 2 values. We're going to see an example of that in a little bit. Okay, but that's finding the 5-number summary. Now let's talk about IQR. I mentioned this in previous notes, but the IQR is going to be a way to measure spread, how spread out our data is. Okay, so our 5-number summary kind of attempts to summarize what the data is doing. The IQR tells us a little bit more about the spread. IQR stands for interquartile range, and it uses percentiles, the first quartile and the first quartile and the third quartile, to describe the spread of the distribution. The IQR is the range of the interquartiles, meaning Q1 minus Q3. And the IQR, just like the range, the IQR is a number. Okay, so we take Q1 minus Q3 minus Q1, and that number is called our IQR. Okay, single value, not an interval. So for the example we just did, what is the IQR of the number of hours of sleep that the group of AP students got? Okay, well, IQR is Q3 minus Q1, so we're going to take 8 minus 6, and that gives us an IQR of 2. Okay, and that's it. That's your IQR. Isn't that nice? Okay. Now, with that 5-number summary, we are going to introduce this new graph called a box plot, or sometimes called a box and whisker plot. But the 5-number summary we use to construct this box plot. The minimum value, Q1, median, Q3, and our maximum value. Okay, so those 5 numbers, you can see how they are used to construct the box plot because they represent specific points on our box plot. The minimum, this right here, and this right here, these are called whiskers, which is why this is sometimes called a box and whisker plot. Those are what we call the whiskers coming out on either side of the actual box. The box goes from Q1 to Q3. Q1 to Q3. So this represents your IQR right here is this box. The median, we just put a line where the median is. Now, the median isn't always centered between Q1 and Q3. Okay? The median is going to be kind of anywhere in that box. And then the whiskers go from the quartiles out to the maximum, or this quartile and out to the minimum. So constructing it, here are some steps if you're more of like follow a step kind of person. You set up your x-axis and you label with the scale. Make sure that you label with a consistent scale though, like we do with other graphs. We don't want to only mark the values of the 5-number summary. So if you go back here, notice how x goes up by 2. Okay, and I'm not just marking off where the 5-number summary is. You want to make sure that you have a consistent x-axis there. Okay. Place the points at each value of the 5-number summary. A box is drawn from Q1 to Q3. The vertical line is the median, not necessarily in the middle of the box, but somewhere inside the box. Okay, and then the whiskers extend out from those quartiles to the min and the max observations, and then we connect the points appropriately. Okay. And we're going to do that with our example from a few notes ago about teacher ages. So now we have teacher ages. This is a different example from the sleep. This is a new one. Teacher ages from lowest to highest. Find the 5-number summary and construct a box plot of the data. Okay, so this is in order where the min is 24 and the max is 51. Okay, so it's a table, but it goes in order. Okay, hopefully you see that. Next, we find our middle value. Now our middle value, because this is an even list, it falls right between these 2 points right here. So our median is 31.5. Okay, so our median is right here between these 2 points. So whenever we go to find our middle value for our Q1, okay, our Q1 actually ends up being between these 2 values, okay, 29. And then our Q3 ends up being between those two values, which are both the same number, 39. So that also is going to be our Q3. Okay. So we have our 5-number summary. Now we can make our box plot. So I'm going to make our graph. I have to go from 24 to 51. So I go by twos. And then I guess if I wanted to, I could also mark off 52 actually to be consistent. But you'll see, like, right? So like the points in between here represent the odd numbers. Okay, you get what I'm saying. All right, so I'm going to start off. You can kind of do this however you want, whatever feels easiest. I marked the min and the max, my whiskers. And then I marked my quartiles, 29 and 39. So notice where I put those. The whiskers go there. And then I draw the box around it. And then I put the median in the middle. Okay. I usually construct the box and the whiskers first and then put the median last and draw that in the middle. But maybe you're someone who likes to start with the median first. Okay. That's up to you. But you construct your box around these 5 numbers. Okay. And that's your box plot. Now, I said with these these new summary statistics with the quartiles and the IQR and all of that, we are now going to talk about a way to mathematically determine if points are outliers. So we've so far defined outliers as points that are outside of our normal data set, okay? They stand out in some visual way. Now, we've said that sometimes we just have points that are extreme values, okay? They stand out, but they're not so far away that they wouldn't be considered part of our data set, right? But there are some cases where they're so far away that we don't want to consider them part of our data set. And we call those points outliers, right? So we talked about how like test scores, if you're consistently getting A's and B's and all of a sudden you miss a test and you get a 0 on that test, how much that lowers your grade. Okay, that 0 is an outlier. It doesn't follow the pattern of your normal test scores. And we have a legitimate reason to not include it, right? If you were absent and you're going to eventually make up the test, why would we include that outlier point in your grade book when you're going to make it up later? Okay, so sometimes there's reasons to eliminate outliers. So we want a way to mathematically identify them, okay? So both of these ways that we're going to talk about mathematically determine if a point is far enough away from the rest of the data to be considered an outlier. So there's 2 ways in this course. The first way is to use IQR and quartiles, and the second way is to use mean and standard deviation. Okay, so let's talk about the IQR and quartiles first. This is called the 1.5 times IQR rule. The other one is called this 2 standard deviations rule. Very informal names, and the formula that you use is basically in the name itself, so that's kind of nice. Okay, but here are the ways for the 1.5 times IQR rule. You find the 5-number summary and your IQR, and then you find what your boundaries are. Now, these boundaries are going to be saying, okay, anything within this boundary is a valid point in my data set. Anything outside of these boundaries is going to be considered an outlier. So to come up with these boundaries, your lower boundary, you're going to compute the Q1 minus 1.5 times your IQR. Okay? And any data below that number is an outlier. Your upper boundary is Q3 plus 1.5 times IQR. And any data above that number is an outlier. So you'll have those 2 as your boundaries. And then anything outside of those is an outlier. Same idea with 2 standard deviations rule. We find the mean and we find the standard deviation of a data set, and then we find boundaries. With the mean and standard deviation, the lower boundary is your mean minus 2 times your standard deviation. And your upper boundary is your mean plus 2 times your standard deviation. Okay. So for both of these rules, we're finding boundaries, we're drawing boundary lines and saying anything outside of these boundary lines is an outlier. So let's look at both of these in action here. So here's the sleep data again, right? And I'm going to go through both ways of doing the outlier test. So I have my summary statistics, I have my 5-number summary, and then I also have my mean and standard deviation listed in that table, okay? And then my data is right there as well, okay? So let's look. 1.5 times IQR rule. Here's how I would do it. I would find the IQR, which we know is 2, right? 8 minus 6 is 2. Then I would find my lower boundary, and here's sort of the formula that I would use. I would take Q1, which is 6, and I would subtract 1.5 times my IQR, which is 2. So 1.5 times 2 is 3. 6 minus 3 is 3. Okay, so my lower boundary is 3. My upper boundary, this is the formula, Q3 plus 1.5 times IQR. So again, 1.5 times 2 is 3. And then 8 plus 3 is 11. Okay. So now I have to see, okay, 3 and 11, those are my boundaries. Anything outside of 3 to 11 is going to be an outlier. Okay. So I look at my data set and I see that all of these numbers, except the 2, which I have highlighted over here, fall in that boundary of 3 to 11. Okay. But 2 does not. 2 falls outside the boundary, which means 2, with this rule, 2 is considered an outlier. Okay. 2 is considered an outlier. That poor person who got 2 hours of sleep before the first day of school. Oof, I can't imagine. No, thank you. All right, now let's do the 2 standard deviations rule. Same setup here, same summary statistics, same data. 2 standard deviations rule. Lower boundary, we're going to take the mean, this is the mean, minus 2 now times my standard deviation of 1.5. Okay, so the IQR rule uses 1.5 times the IQR. The 2 standard deviations rule uses 2 times the standard deviation. So your lower boundary then becomes 3.64. Your upper boundary, again, your mean plus 2 times your standard deviation, which is going to be 9.64. So anything below 3.64 or above 9.64 is considered an outlier. And again, 2 falls outside that range. All the other numbers fall between 3.64 and 9.64. So 2 is the only outlier. Okay. Now visually, in a graph, we can see outliers pretty nicely. Okay, we can see them in histograms nicely, dot plots, stem plots. We can see outliers. In a box plot, the way we have written the box plot so far, it makes it difficult to see outliers because the whiskers would extend all the way out to number 2, right? And we don't know, the way the box plot is shown, we don't know individual values. You don't see individual values in a box plot. So we don't know how many. We know that 25% of the data falls in this whisker, but we don't know how many that is. And we don't know if they're outliers or not, which is why we have a modified box plot. And a modified box plot is a box plot, but it shows outliers. Other graphs show outliers easily. A modified box plot is what's going to show outliers more easily. Okay. Any outliers, but only the ones identified by the 1.5 times IQR rule. Because we use quartiles to construct the box plot, so the only rule we follow for outliers is the one involving quartiles. Okay. Any outliers will be marked with a dot or sometimes a star, and the whisker will extend out to the next observation within the acceptable boundary ranges, not the boundary ranges themselves. And that's the biggest mistake I see students make when they're making this by hand, is the whiskers only extend out to the data set that is still within the boundary, not the boundary itself. So I'm going to show you what I mean with an example here. Of course, here's the sleep example again. Here's my 5-number summary. And we know that 2 was the only outlier. Okay. All of these other numbers fell within the acceptable range. 2 was the only outlier with this rule. So I'm going to mark 2 with a dot because that's my outlier. Okay. And then the right whisker will now extend to the next value in the boundary, which is 4.5. Remember when I did my rule, the boundary was 3 to 11. Okay. It was 3 to 11. And anything outside 3 to 11 was an outlier. But 4.5 is the next data set that's within that boundary. So my whisker extends to 4.5. It does not go to 3. Those boundaries do not come into play in your box plot. I can't stress that enough. The max is not an outlier, so the whisker extends out to the max value of 8.5. The whisker does not extend to 11. Again, the 3 to 11 were just boundaries for determining outliers. They don't play a role in my box plot. Then I extend to the Q1 and Q3, and then I have my box with my median at 7. Yeah. And there's my modified box plot. Okay. So you can see now it's very easy to identify outliers. Okay. It's very easy to identify that 2 as an outlier in your data set. Okay. Now the last thing we're going to talk about is interpreting data in a box plot. And this is a very common AP question. So I'm going to go through different examples of questions that you might be asked and just how we can use box plots to answer them. So here data is represented in the 4 box plot measures. It measures the same variable across 4 different groups. Okay, so we're almost comparing distributions in this sense. A, B, C, D are my 4 groups, and my mystery variable, again, just something I kind of made up here, something that I'm measuring across 4 groups. Okay? A question that might be asked, which of the groups has the largest range, right? How can we determine which group has the largest range from a box plot? When we know the range is max minus min, so we would have to determine that for each of these groups. Okay? So I made a little table to organize this. In A, I would find my max, which is 30, and my min is 10. And I would take 30 minus 10 to get 20. So the range of A is 20. And I would want to do that for each of these. Okay? Maybe you can kind of see which one has the largest range just by looking, but I want to just go through the work. Okay? Here is B. Group B, 32 minus 7 has a range of 25. C has 30 minus 13, a range of 17. And then D has 20 minus 8 with a range of 12. Okay? So which of these groups has the largest range? Well, that's going to be group B. Okay. All right. And you can hopefully see that now just by looking at it, but we can confirm it with numbers as well. Another one, which of the groups has the largest IQR? Okay. Again, maybe you can kind of look at it. I don't know. A and B kind of look close. You know, C is definitely probably the smallest, right? You can kind of look, but let's confirm this with numbers, right? So A's IQR is 25 minus 15, which is 10. B's IQR is 20 minus 9, which is 11. C's IQR is 23 minus 18, which is 5. And then D, 16 minus 10, has an IQR of 6. Okay. So that does confirm B also has the largest IQR. Barely, but it does. Okay. All right. So those are straightforward questions of just looking at what values we can determine from the box plots, right? Now, some other things you might be asked to write a description sometimes. Like, for example, number 3, compare the median and the quartiles between A and B. Okay, so if we have A and B, we want to compare the quartiles between them. All right, so let's take a look at first the medians, right? So the median of A, how does it line up with the median or the quartiles of B? Well, Group A's median is actually equal to Group B's third quartile of 20. Okay. When we're asked to compare things in AP statistics, we want to make sure that we are using comparison words. And I'm going to talk about this a little bit more later on in different section of notes. But comparison words means we don't just want to say, hey, A's median is 20 and B's median is 12, right? Those aren't comparing them. They're just stating what they are. You want to try to relate them, okay? Whether it's larger, smaller, same, whatever they may be. So here, Group A's median is equal to Group B's third quartile, okay? What about the first quartiles, right? A's first quartile of 15 is larger than Group B's first quartile of 9, okay? So this is just an example of a way you can compare using those comparison words between two groups here, okay? Something you might be asked to do, most likely. Here, compare the median and the quartiles between C and D. So now we're just looking specifically at C and D here. Okay. Well, the median of C is equal to group D's maximum of 20. Okay. And then what about the first quartile? Well, actually group C's first quartile of 18 is larger than group D's first quartile, the median, and the third quartile, right? Everything about group D is shifted down there. So I say that with those comparison words, the larger, equal, smaller, okay? Use those comparison words when you're specifically asked to compare, okay? All right, and that brings us to the end of our notes here on Boxplots and Outliers. Okay, thank you guys so much for following along. If you have enjoyed this video, please hit the like button and subscribe to my YouTube channel for more great AP statistics content. Until then, I wish you endless statistical success, and I will see you in the next video.